Hello students, today I am going to discuss an MCQ questions which had been given in 1995 advanced level paper. In this question it says a bird flying at a height of 40 meters with a speed of 10 meters per second drops a small fruit from its mouth. If free fall is assumed, the speed of the fruit just before it reaches the ground is, we are given 5 answers that we have to find this correct one. Here, when bird is moving at 10 meters per second, it releases this fruit. You can see in this animation when it's been releases, it has 0 vertical velocity component and the horizontal component of the fruit is 10 meters per second. That is same as the bird's horizontal component. And during the motion, the horizontal component does not change. It is because there's not any force acting on this fruit horizontally. But the vertical component not like that, it increases because of gravitational acceleration. In this question it says if free fall is assumed, it means that we are asked to take gravitational acceleration as the vertical acceleration acting on the object. When we are going to find the speed of the objects just before it reaches the ground, we have to find the velocity first. The magnitude of the velocity is the speed. When you're going to find the velocity, there are 2 components on this object. One is the horizontal one, other one is the vertical one. So once we found the vertical, we can find the resultant. So that is the speed. If we just another object when the fruit is released, that both of them are moving together vertically. So instead of find this velocity, we can find this velocity. When we are going to find this velocity component, we can use the data which had been given in this question. We know the displacement, it is equals 40 meters and also it is acting downwards. Then we know the acceleration, which is known as the gravitational acceleration, and it is also acting downwards. Also we know the initial velocity component, that is u equal is 0. When it is reaching initially, the velocity is 0 and it's also acting downwards. So these are the things that we know, and we have to find this v. So we have to select a suitable motion equation from the list of motion equations that we are given. Since we have to find v, we can use this, but the thing is we don't know the time. This equation cannot be used because it doesn't help us to find v. But when we come to this equation, it has u, acceleration, and displacement. So this is the suitable equation that can be used for this sum. I'm going to use it. V squared equals u squared plus 2as, and when we use this equation, we have to put the direction also. Then let's substitute these values for this equation. V squared equals u means 0 squared plus 2, acceleration is 10, and the thing is when we substitute these values for the equation, we have to consider direction. So this equation's direction is downwards and the acceleration's direction is also downwards, then we can put plus 10 here. Then the displacement, it is also acting downwards, so we can put plus 40 meters for that. So these are the things after we substitute. Then v squared equals 0 squared means 0 plus 2, 10 into 40 means 400, and we can further simplify this. V squared equals 800. So I'm not going to further simplify this because I need only v squared to find this resultant. So then if this is the fruit, there's a horizontal component of velocity acting on the fruit, that is 10 meters per second, and also a vertical velocity component, just we found it like v. So for these two, there's a resultant that we are going to find. So the resultant squared equals v squared plus 10 squared, and v squared means here we found it as 800 plus 100. So then 800 plus 100 means 900, and we know this 900 equals the square of 30, which means the resultant equals 30 meters per second. So this is the speed, the 30 meters per second, and it is what we have to find. So from these answers, it is the fifth answer. Thank you very much.